Hello, welcome back. My name is Tracy Pendo Onim and I'm a software developer building fault-tolerant applications customized to client needs with Elixir for 5 years now. Do you remember Supermarket Y, where we had the checkout process taking forever because customers were being handled one at a time by one cashier? On today's episode, we shall actualize Supermarket Z concurrency magic with Elixir GenServer. First, let's have a quick look at our current checkout process. With the current setup, each checkout detail received is being handled one at a time. It takes 4 seconds to complete one checkout process. 1 second is for saving the details into the database and 3 seconds for processing the payment. Just like Supermarket Y, it works, but it's slow. If you're processing 10 checkouts, it will take 40 seconds to complete. So let's run the checkout process and see. So that is the model name, and I call the process function, which takes in the checkout details that were already added to the EX script file. If we run this, we shall see some of the information printed on the screen. We shall know the starting time and the time it took for all the checkout details to be processed. And also we shall see the difference between the end time and the start time. I'll run this. So remember, it takes 4 seconds for each checkout to be processed. Let's say after the 10th checkout process, we can see the total time taken is 40 seconds. To fix this, we shall use GenServer to create isolated process for each checkout request received. The aim is to build a checkout process that is fast and efficient. This way, we are guaranteed that tasks will run concurrently, just like having a cashier for each customer. Let's get started with implementing a GenServer that will be responsible for each checkout request. Therefore, I'm defining our server as checkout server, that is dev module checkout server. Within our server, we'll need to have access to the GenServer callback and functions. Therefore, pass use GenServer. Within our checkout server, we need to know which callback and GenServer functions to implement. The first callback that we shall implement is the init callback of RT1. If we fail to define this callback function, we will get a warning that it's required. This is on the server side. On the client side, the function we need is the startlink function. This is the function that is responsible for starting the GenServer. Let's start with these two first, then we move to the next step. We can start with the startlink function. That is the client side. I'll define a startlink custom function. This is a custom function, not from GenServer, which will take one argument, then invoke the GenServer startlink function inside this. Startlink is of RT2. It will take in the module name. Let's start with the startlink function, which is on the client side. I'll name the custom function as startlink. Takes in an argument. Then inside this function, I will invoke the GenServer startlink function, which takes into argument the module name. Then you can pass the argument here. So this argument will be the one passed to the init callback function once the GenServer process has been initiated. On the server side, we are adding the init callback. Let me remove this here. Have the init callback. The init callback takes in one argument. This argument is the one that is coming from the startlink function. I'll call it state, and we shall return an OK state. By returning an OK state, you are declaring that once the GenServer process has been started and the init callback returns an OK state, that means that the GenServer process has been started successfully. We can start our server and see if up to this point it's working as expected. Spin up your server by running ix-smix command. Checkout server startlink function that I've defined, passing any argument even if it's an empty list. And yes, we have managed to start the GenServer process successfully. You can see we have an OK and a PID. So this PID is the process identification of the GenServer that we have just started. The next step is to customize our checkout server, start a process to be able to start a unique process for each checkout. We shall do that by registering our GenServer with a unique name. And to register the GenServer, we shall use the name option, which we shall pass as a third argument to the startlink function. We can pass it as 1 and try it out. Recompile the changes, then restart the GenServer process. And we have a problem. We have an argument error, expected name option to be one of the following, either nil, atom, or a global term, or a tuple of an atom via module and a term, but we passed a string. It does not take a string as the name. I'll change this to an atom. Let me pass it as 1. I'll then recompile the changes again and restart the GenServer process. We have been able to start the GenServer process, and the name that we have registered it with is an atom 1. Let's see the process info. I'll pass it the PID. I did not pattern match. I could easily retrieve that info. Oh, I can't retrieve it. Let me try to retrieve the PID. So we have an OK PID, and I'll call AX that was responsible for it. That is a V4. Now I have the PID. Let's check the information of this process. And you could see that the process has been registered with the name of an atom 1. We are on the right track. Since we are starting a GenServer process for each checkout, our argument can be the checkout details, and we retrieve the name from that information. Let's see how the checkout details look like. This is the checkout details, and the only unique thing here is the phone number. Let's add an ID here, and this ID will be the number for each checkout detail. This is X. I'll pass the variable X. So with the ID, we have a problem. I'm trying to see if it's possible to convert a string number into an atom, which I don't think is possible. We can try that. String to atom, and I pass it a string 1. I don't think this will work as we intend it to work. In our case, this name needs to be unique to be able to start a GenServer process for each checkout. I have decided to pass the literal string within the inner map, and each value within this list will be passed as an ID and converted to an atom. We can now go ahead and retrieve the name from the argument, which we know is the checkout details. Actually, we can retrieve it by calling ID. What if the argument is an empty map? Which you can make the argument default to an empty map. If an argument is an empty map, the name will be nil, and that will also be a valid argument. There's no problem. Now that we know that the argument is the checkout details, let's go ahead and retrieve the name. To retrieve a value from a map, we shall do argument and access the ID value. We can recompile the changes and see if this actually works. I need to restart the IEX because we changed the IEX script, and for it to pick up the change, I need to restart it. Let's see what we have in our checkout details. The ID has been updated as expected. Let's start a GenServer process for each checkout. I've closed the IEX. That will be fast. I'll do inner map. Actually, let's just start for 3. I just need checkout details information and see which one I can use. Let me copy paste this. Checkout 1. We have that. Then let's call the startlink function, the server startlink function, which takes in the checkout details. We have been able to start the GenServer process, and you can see it has returned an OK and a P. Let's check the information of this process, and again I forgot to pattern match. That is V3. To check the information, I will call process.info function and pass it the PID. You can see the registered name is 1, and that is what we have as an ID. Let's do another one for checkout detail ID 2. We can do for a random number, even 6. Checkout, this is 6. Paste that, and then let's call the checkout server startlink function and pass it the new checkout detail. This is another server started. I keep forgetting to pattern match. Pardon me for this. This is from IX8. Let's see the first PID we had. That is 402. And this one is 404. Let's check the process info of the new GenServer process that we've just started. Give it the PID. You can see the registered name is 6. This way you have been able to register each GenServer process with a unique name. The checkout server will be the one responsible for saving the checkout details into the database and processing the payment. We need to make changes within the server. In the init callback, instead of returning a tuple of an atom and a state, we can add a third value within this tuple, which is a tuple of an atom continue and a continue argument to be able to perform a post initialization task. That is a task that is done after the GenServer process has been initialized. Have an atom of continue and a continue argument. So the continue argument can be anything, and what we want to do is to process, can be any term, that is we want to process the checkout. Just call it process checkout. If we run these, recompile the changes first, then let's start the GenServer process. The GenServer of checkout 6 was already started. I'll need another checkout detail. I can copy paste this, maybe 7. I'll need a way to change this name. Let me just change it from here. This is 7. I want to try out the new change and see. Checkout 7. You can start a new checkout process called start link and pass checkout 7. This is a new GenServer process, and we have an error, and the function that is undefined is handle continue. This error takes in process checkout. This is the continue argument that we have passed in the init callback as the return value. This is the state. You can see it looks similar to checkout 7. Let's see the ID and confirm. This is checkout 7. Then it only have 2 arguments, the continue argument and the state. Therefore, we need to also define the handle continue callback within the checkout server. Let's define the handle continue callback. Takes in the continue argument, which is the process checkout. The state is our checkout detail. Then for the return value, we shall pass no reply and the state. It's within the handle continue that we're going to save the checkout details to the database and also proceed with payment processing, similarly to what we were doing here. Therefore, I'll just copy this as it is and paste it the other side, on the server side. Also, we need to copy the private functions involved. I'll cut and paste it here. Now let's see what we have. Replace the checkout with the state. Also, I was thinking, since we are starting a GenServer process for each checkout received, instead of leaving the GenServer process idle after it has completed its task, we can terminate or stop that GenServer process from running. Therefore, instead of returning a no reply state in the handle continue callback, I will replace this with a tuple of an atom stop, pass the reason, normal, and the state. This way, after the task is completed, it will stop the GenServer process from running. I don't see any other change that we might need. Now we can be ready to spin up our server and see if it's working as expected. Before we do that, there are some changes we need to make within the checkout. This is the process. When the checkout detail is a map, it was the one responsible for saving the detail and making the payment. Now we need to replace this. Here is where we are going to call the checkout start link function and pass the checkout detail. That's it. Now we are ready to test our new implementation. Remember, with the sequential checkout process, it took 40 seconds to process 10 checkouts. Now let's see how long it will take. Let's open the yes. I'll have to recompile for the new changes to be picked up. We are good to go. The checkout details, I think this is intact. Now we are not calling checkout start link function directly. We shall use the client side. We shall use the checkout process function, which takes in a list of checkout details. So that is checkout. I should have renamed this model to checkout client. Let me just do that right now. Checkout client, just to be easier to differentiate. I'll have to recompile again. Call checkout client and checkout client process function and pass it the checkout details. We have called IO puts, which will print the information. This was not supposed to be ending time. Let's change this to time taken. I think it's clearer that way. Compile, checkout process, checkout client dot process, and pass it to the checkout detail. Then you can run that. Have you seen what just happened? Starting time was at 5:54, end time at 5:54. Time taken 0. Have you noticed how much faster the checkout process is now compared to how it was before? You can see the time taken is 0. So this is in seconds, and because the default unit for time diff function is in seconds, we can change that to milliseconds and get the actual difference, because there's a difference between the starting time and the end time. Let's update that in here. We can pass the unit as milliseconds, recompile the changes, then call checkout client process function. We have a warning, deprecated time unit milliseconds. A time unit should be second, milliseconds. I've just add an S. Let's change that. I'll recompile the change and then call the process function again. Even in milliseconds, the time taken is 0. Do I need to change to microseconds? But there's a difference. There's a tiny difference between the starting time and the end time. It's much faster compared to the sequential process that we had before. I have just realized that we are not capturing the correct total time taken. And this is because the time indicated here as the time taken is the total time taken after each process has been started. Actually, what I want to do is to increase the sleeping time to 1 minute instead of 4 seconds. Then I will check this against my system clock. So after the last printout, because we have the printout, you can see the printout after the payment has been made for each detail. After the last printout has been made, I will compare the starting time and the end time using the system clock. I have lost ideas of how I can validate, actually, because we are starting a process for each checkout, and if I try to validate the time, I'll be validating for each checkout and not for the total processing time. Let me start the server and call the checkout client process function. Pass it to the checkout details. Yeah, it's 9:34. Let me run it. So remember, each checkout is now taking 1 minute. It takes 10 seconds to save the details and 50 seconds for each checkout. Now it's 9:35 and we have completed for all the 10 checkouts. That means it takes 1 minute to process 10 checkouts. If it was for the sequential method, one checkout takes 1 minute. That means it will take 10 minutes to process for each checkout. With the updated implementation, we are able to handle the checkout process independently and simultaneously, and that's why it took 1 minute to process 10 checkouts. That is the power of concurrency in action. If you're interested in diving deeper into GenServer or explore other Elixir tricks, let me know in the comment section. Next up, I'll be talking about supervisors, because even a GenServer needs a manager. Don't forget to follow for more tutorials. See you then.